Welcome on this lecture, and in this lecture we'll study the how you can differentiate aldehyde, ester and acid through NMR spectroscopy. Okay, so ester, if you see the ester, the molecular structure is the this one RCO. Okay, and in this you can see the carbon is attached to the oxygen. Okay, and if you see the another compound which is aldehyde, so all of you know that it is the RCHO. Okay, so CHO is the main functional moiety of the aldehyde. Carboxylic acid, if you see the carboxylic acid, then it is the COO. Okay, and hydrogen is will attach from the oxygen. Okay, so these compounds, first of all you should know about the functional moiety of these type of compounds. After that you can see the C13. You should be know about that, because if you synthesize these type of molecules, then you should be know about the starting material, means NMR of starting material, as well as product NMR, means you should be know about the what is the del value of C13, as what is the del value of the proton NMR spectroscopy. Okay, by which you can differentiate, because in the lab you will synthesize this one. So your precursor as well as compound, the NMR spectroscopy regarding these compounds, you should be know about that. Okay, so del value, first of all, see, you should be know about the proton NMR spectroscopy. Okay, so if you see the OCO, okay, so ester will appear in the 3.7 to 4.1 ppm. Okay, so if these in this region splitting pattern occur, then you should be know about that the carboester will be present on this compound. Okay, the del value is 175. So two compound determine the functionality of the ester. Okay, the another is carboxylic acid. It is very characteristic peak, and it will appear the 10 to 13 ppm, means these proton will appear as a singlet in this region 10 to 13 ppm, while in the C13 spectroscopy you can see these peaks, means these carbonyl peaks of acid in the region of 162 and 80 ppm. Okay, because it will vary, you can appear 165 or you can see in the 170 or 175, so it will vary. Okay, after that aldehyde, it is the most characteristic compound, and this proton in the NMR spectroscopy will appear in the 9.5 ppm, while 205 ppm these carbonyl peak appear. Okay, so these three compounds is differ from each other. Okay, so by which you can differentiate ester, carboxylic acid and aldehyde. The next one, how you can synthesize, in actually the purpose behind this discussion is that you can easily synthesize in the lab this compound ester, either ester or carboxylic acid or aldehyde. So ester, it can be synthesized for primary alcohol with acid. Okay, and in the acidic medium you can prepare the ester. Okay, so first of all, how you can determine that you can prepare this one. So you should be take starting material and this one, and 1:1 millimole, and you can obtain this one. Okay, so starting material NMR, you should be know about that 0.7 1.3 ppm appear for the hydrogen. Okay, and this CH2 will appear in the aliphatic region. Okay, and this carbon appeared in the 40 to 80 ppm. This COH, means carbonyl, will appear in the 165 185 ppm. So these peaks will be disappear, while in the NMR spectra new peaks will be appeared in the 170 ppm in C13, while 2.1 to 2.6 ppm in the aliphatic region. So by which these peaks will be disappear and these will reappear. Okay, so that's why, means these new peaks will be appear in the NMR spectroscopy when these products will be formed. Okay, so similarly you can see the primary, this is the tertiary alcohol, this is the acid, you can prepare this one. Okay, and it is the aromatic ester. Okay, the another I have also mentioned the 110 170 ppm in C13 NMR, while this will peak not will be changed in the products, while change will be occur in the new peak. This is because this is the ester peak which will be appear in the NMR spectrum. Okay, similarly carboxylic acid can be synthesized from the halides, organic halides, in the presence of NaCN. You can prepare the RCN. The peaks RBR appeared in 25 to 65, and in proton NMR 0.7 to 1.3 ppm appeared, while 40 to 60 ppm appeared for the CN. Okay, means in the C13 spectrum. The new peak will be when acid will be formed in your round bottom flux, because reaction is occur in the round bottom flux. Then what happen here, when you will check from TLC, then new spot will be appeared, and it will be the acid. Acid is the very polar, and it TLC it appeared in the bottom region. Okay, so this after separation, you can separate this compound and take the NMR spectroscopy, and will appear 165 to 185 ppm. Okay, so 10 to 12 ppm appeared in proton NMR spectroscopy. Similarly, synthesis of aldehyde will be occur, and 40 to 80 ppm COH. Okay, and oxidation reaction, through oxidation you can prepare the acid. The new peak will of acid appeared in 165 to 185. This one, and the proton NMR spectro in proton NMR, this proton will be appearing 10 to 12 ppm. Okay, so these are the some the two question actually has been solved in this lecture. First one is how you can differentiate aldehyde, ester and acid through NMR spectroscopy, while how you can synthesize in the lab. Okay, I will discuss also that during the synthesis of these starting material, first of all you should be know about the what is the precursor. Okay, suppose that you are going to synthesize ester, this one OCOR. Okay, so it will the starting material will be the OH, and another is the COH. Okay, so first of all you should be know about the NMR of these compounds. Okay, because one reaction is occur 1 millimole and 1 millimole, or you can take 1 mole. Okay, so these ratio will be taken. Okay, COH appeared, this proton appeared in the region of 10 to 12 in the proton NMR spectroscopy. So first of all you should be know the proton NMR spectra of this starting material, by which when these will be formed. Okay, then new peak will be appeared for ester. Okay, it is the 0.2 to 4 ppm. Okay, so these new peak appear while these starting material will be consumed during the synthesis. Okay, mostly what happen here, the synthesis will be occurred in the estering. Okay, means hot plate is used, and in the first of all you will use the condenser, and in this like that. Okay, so this and okay, so this one condense. Okay, so in round bottom mainly what happen, round bottom flask is used. Round bottom flask is used for the synthesis of any organic molecules. Okay, so in this, first of all you can use this one, you can use this one according to the literature, how much time will be taken. Okay, so you will check. Okay, so after synthesis of this one, this starting material will be consumed, and you will take the TLC of this mixer. Okay, so TLC, if this is the starting material, this is the starting material, and this is the starting material, two starting material. It is the actually starting before conducting the reaction, you will take the some mixture of this starting material. Okay, in which two compound will be present, OH and acid. So you will check after 1 or 2 hours depending on the literature, how much reaction will be how much time taken by the reaction for completion. Okay, so first of all you will put these spot in this, and the new after 2 hours you will take the some mixture and spot in this region. Okay, so this is the after running a particular solvent system, you can see these spot will be disappear, and these spot will be not disappear. These will be the starting material, OH and OS. But in this, if you see, these new spot will be appeared for ester, and these spot will be disappear in this. Okay, because after 2 hours this starting material will be consumed. So this indicates that your product will be formed. Okay, so after that you will close this reaction and separate this reaction mixture. Okay, but after that you can analyze through NMR spectroscopy by this way. Okay, so it is the basic idea how you can prepare how you can differentiate aldehyde, ester and acid, and how you can prepare ester, carboxylic acid and aldehyde. Okay, so thank you for watching this video, and if you have any queries regarding this lecture, you can write down your comment in the comment box. I will solve your problem. Okay, definitely. And if you are new on this channel, please like and subscribe. Okay, by which I will in the next video I will prepare a particular topic, okay, regarding the organic chemistry. Okay, so thank you for watching this video.